Hey everyone, we're going to be working on the fuel tank. Okay, let's check out your view. See what I'm working on. This might be a little loud, careful. There, that works, but yeah, go ahead. That's not good. Still not good. Oh, we lost our thing. Maybe if we make you taller, that will work better. Yeah, but you still can't see me. That's just so lame. Like, what does it take? Holy crap. All right, so I'm sort of here. Okay, cool. First thing we're going to do is we're going to vacuum our work surface. There's a lot of vacuuming involved with what I'm going to be doing. I think the vacuuming has more to do with my OCD than anything in particular, but there's a lot of static electricity with the fuel tanks. So I'm always trying to abate the static electricity in all the chips. All right, this is the next tank. I'm going to run real quick and check the build sheet. So yeah, a little crazy. I'm not the best prepared. All right, this is going to be for Carl. It is this tank. It is this color. That's important. So I'm kind of torn a little bit. Like, do I bring you in closer to see more detail? Maybe, yeah, let's go ahead and do that. So there might be a little bit of noise when I adjust you. Okay. So up here is a seam along where the mold sections meet. And the router kind of jumps up on this, so we want to make this really smooth to help with that physical transition. And transition. A lot of my use of the hobby knife, you'll see I have one hand holding the handle and then the other one pushing, and that helps prevent flyaway. Let's go ahead and get this bit over here. So for the most part, you can be fairly not concerned with how you treat the tank, except for where the O-ring goes that seals the inside to the outside. you know, it matters a little bit there, so you don't want to screw that part up. I seem to do better some days than others at this little bit right here. Okay. Great job. We didn't piss off the important part. Now I'm really careful through here because if you, or me, slip the blade across where the O-ring goes, you dig this little trench. And that little trench is impossible. I mean, you'll eventually get it fixed. But I'll be here an hour going after that trench with like a file, sandpaper. So it takes a minute to get that fixed if you are careless with your blade and draw a line across where the O-ring goes. Now, other than like a specific sharp little trench, you'd be shocked what an O-ring will seal against. They can be wavy, they can be ugly. So these two holes right here are where vent tubes provide venting for the process. The mold cannot be sealed because you have such a tremendous change in temperature. This one is where the breather lives for the filler cap. And then the filler itself will go in this hole. We're going to route this out. One thing about this particular tank, there's a separate piece in the mold where it's round. This is not on center. So a lot of folks will see that and go, oh, well, you missed the hole where it goes. And it's like, no. Trust me. Oh, no. We put a lot of effort into getting this tank dialed in. I think we are somewhere around 13 or 1,400 parts made. I know we were over 1,000 while still in California. And then I'm up over 100 already here in Georgia with ones that I've made with my own hands. So these tanks are generally good. So like in theory, you would wait to test. I mean, you'd wait to keep trimming until after you've tested it good. I haven't had any of these tanks actually leak. Check back here. So this is a little bit lumpy. We'll probably end up taking a Dremel to these. The flatness of the sections really just has no rhyme or reason. Okay, so here is a small void pushed up next to the insert. That's kind of normal. I tried to make trouble with the blade there. So what I'm doing is I'm probing for these voids where the O-ring goes. So like over here to the side, it's not an issue. It doesn't go there. Now the pocket itself is not a problem because where the inserts live, they're fully encapsulated. And so instead of being a perfect semicircle on this one, it's going to have just a little extra over there where this air kind of pushed the whole thing away a little bit. So we actually apply RTV to the mold to help stop those. Now this tank was made in early April, and so we noticed a few tanks having that issue. So after this one, we applied that stuff. So, okay, next step, we're going to put the routing plate on. I have a tool kit for each process I do in the shop. And it'll have the specialty pieces to do with any workflow. Each of my little tool kits. I'm going to get some eyes and ears. We're going to use a router, and we're going to use the vacuum. I'm kind of sensitive to loud sounds. That's thank you, autism. And I don't probably need hearing protection, but it really makes me jump out of my skin. So the router has a shoulder on it, and so that's like an offset, and then this ring here is larger than the actual hole by that offset. Okay. Vacuum. So I always double check after routing an area to make sure I didn't cut a corner. It's real easy to go to the inside and you don't notice. And then on this one, the O-ring goes back here. So I always start here in case something goes wrong. Who knows? Hasn't happened yet. Hopefully never will. And then we're going to get an attachment and vacuum a little more. And so that was the core that you heard rattling around. Early on, we learned you can't actually judge how well one of these tanks seal by how flat it is. So we've seen them like, this is pretty lumpy. You might even be able to see it in the camera. Like I've seen them not have a problem and be this lumpy. And I've seen them look smooth and then leak. So it's just a matter of figuring out where the air is escaping and then dressing that to make it happy. Typically, the inserts raise up a little bit above the surface and it removes some of the clamping force. This is a pretty high, these two are really high. I'd be kind of surprised if that did not leak. This routing guide plate is a little bit convoluted because of the extra nuts I have on the screws. And that's because to have the height correct between the front and this one, we had to raise this guide plate up. And the quickest solution I came up with was to just double nut screws on. Have to be tight, no matter what you do. If you have loose collars, sleeves, screws, anything up here, they fall into the hole. You would not believe how much effort trying to make it not do that. So same deal again. I'm not particularly worried about eyesight as far as this, but it helps me see. Plus, you never know if something does go wrong. I'd rather have something between me and a hospital visit and huge bills. workshop videos is on making the battery cables. Literally, we supply an extra long battery cable just to adapt our tank to the motorcycle. And honestly, it's like impossible to have somebody make those for you, so we just make them ourselves. And so for this order, I had to make some cables. So weird thing about the open nozzle end, it pushes debris away, sucks it in. So we use the smaller tip to go inside to try to get chips. You will probably be shocked at the amount of times and chips I pull out from the inside of this tank. So here's the core we cut from the filler at the other end, the round one. The tank is anywhere from 200 to 300ths of an inch thick. So, it's roughly 1/4 inch. Basically, we're going for a minimum thickness of like 175 thousandths. So by shooting for a bare minimum of 200, we're more than safe. All right, so now we have to be super, super careful trimming this edge. It's a little furry. We want the best presentation possible. I wonder if I cut in a little bit there. All right, let's get the knife away from there. So to make sure that the holes line up correctly and it seals for the customer, we use a factory piece. This is the same casting as for the Hypermotard, but this one is actually for an Aprilia, and it's made by Bitron, the same company. And so they swap out the pieces depending on which manufacturer. And the thing you just saw as I dropped the screw, you'd be shocked how many times even now I flip this over to look and I dump all the screws. So there's lots of static clean, gosh, everywhere. So using the factory piece is great because it confirms that the screws will line up, and it also confirms that this interface will hold fuel. I don't use a power tool for this part. the first time anyway. If I have to take it off and on and off and on, and it's like, once it seals, I'll use a power tool. But until then, I just use a Phillips head screwdriver. I like to use Phillips head hardware for most of production because it's really great at repeatability and speed. It's much faster to engage screws with the correct Phillips driver instead of trying to use Allen keys all the time. I can use 2 sizes of Phillips driver across 4 sizes of screws. With Allen keys, you can have up to 6 sizes, depending. Check out the other piece just straight up fell out of the other opening. We're going to run the vacuum. All right, we're going to trim up this just a little bit. Got to keep that knife in that hole because otherwise, I'm telling you, I've made it slip and it's really a sad time. I haven't yet ruined a tank so badly by cutting where the O-ring goes, but holy crap, it takes some effort to fix. All right, we're done up here. We're gonna leave that the way it is. So I use a stock casting for the filler. Check underneath. Check the O-ring. It's easy to get a leak with all these chips running. And I intentionally do not glue the O-ring into place. I want no cheating involved whatsoever. I want it to be as close to the customer's experience as possible. These 7 screws rarely are all perfectly aligned. Looks like this one might be. Oh, okay. So yeah, these all come out perfect every time. Wow, that's pretty cool. Almost always a couple of these inserts are raised enough that we get leaks and they need to be dremelled. That kind of squeaking is normal. So you want to start each of the screws a couple threads before you drive any of them home, and then go back around and finish driving them in. All right, those are all good and tight. This is the testing fixture. It's washed out a little. What we have here is a 5 psi regulator, a needle valve, a pressure gauge, and a different than the shop air connector. We don't want to put shop air onto this. On this particular tank, this portion right here will blow out at about 20 psi. There's a dent in the ceiling from when I did that. All right, let's go turn the air on. Don't fall. So the air compressor is around the corner. I'm gonna turn it on. All right, let's throw some air in here. Already, it's making some noise. All right. That's a little unusual. It typically doesn't just plain blow air that much. So let's double check that we didn't put a piece of plastic in there. That looks really flat. I don't see it. I mean, you heard it. Should we just repeat it again, hoping for a different result? Okay, it does curl away a little bit, and those inserts are pretty lumpy. So, all right, we're doing that. We're doing the job. And also, like with the knife, don't dig a trench where the O-ring goes. Really sad. Every time. So you'll see I kind of try to always go from the outside. Not today, Satan. That's a little better. So we've always been very much about transparency with the business and quality. Um, Pretty much, we don't compromise on quality ever. I mean, there's perhaps occasionally a rare thing we do that's better, or that could be better, but we base our quality on best practice for an industry, as well as the results we've had with customers. And so, um, the tanks we make are made such better process than everyone in the industry does. Um, Manufacturers don't use dedicated pressure testing. They'll put their thumb in a vent hole or a rubber plug, and then they'll put it in like a fish tank with an air tip in another vent and just give it air and look. A little um, early on, we had to establish a kind of rule for how flat this had to be, and we didn't test these. We didn't test these in our own until we started making the tanks ourselves here in Georgia. So every step of our process of making tanks, we've gone from the consumer side all the way towards now everything is on us. Technically, the only thing we don't do is we don't pulverize our own powder from pellets. We buy pre-pulverized powder. But that too is a quality thing in that then we can't screw that part up. We've had outstanding results. Black crosslink is one of the hardest materials to run and get the recipe. And we rarely have a bad part. So we do pretty amazing molding, like quality-wise, especially with the black crosslink. People would be like, you can't just do that. Well, I did. A description and a line. Okay. All right, let's give this another shot. Hopefully we don't have that many. If we did, I would probably just go get another tank because we have more. Building pressure. Yeah, it's definitely, there's not enough clamping force here. We're just gonna go get another tank. You see how tight the sealing surface is, except for at the very back? So I guess now we finally have what could be a bad part. If we ever get into a crunch, we can actually, we have a belt sander and we'll sand this whole surface down a little bit and then that'll be the fix. I've saved a bunch of tanks doing that, and if I didn't have literally 2 more of this black tank on the shelf already molded, we'd be doing it to this one right now. Let's make some notes. Okay, that is this tank. All right, I put that it has a dip. That was not the plan for today. Oh, interesting. This one's actually, I went in the wrong order. This one's made before that one. Looks flat to me. I don't see any of those voids on this one. That's nice. So this one is 92, 329. So I saved the cores from the filler caps. I don't know. I don't know if I ever need to prove I did it right, but it just seemed to be the thing to do. I'm pretty careful with our process, so that the temperatures are always recorded, and we try to keep those consistent so that we have the most consistent parts possible. Also about temperature, we contacted Exxon, who makes the resin, and they said that to ensure the best cross-linking occurs, you need to reach 410 degrees Fahrenheit inside the mold for at least a minute. And so the way to do that is with temperature strips. They have blocks that change color when they reach a temperature. And so for each combination of tools on our arm, we have temperature strip testing as well as notes on the bake cycle. And then we also, like subsequently, we don't use temperature strips on every bake, but we take infrared measurements of the mold temperatures at several stages of the process. And that's how we make sure to get as consistent production as possible. I guess I can check. No messages. Okay, that's great. I actually emailed the customer getting this tank, and I was like, hey, if you subscribe and get a notification, you'll get a notification when I go live, and you can watch me work on your tank. So like literally, he could be watching right now, but I don't think he is. I don't think anyone's watching. I only have a couple of people who check in regularly, and they're used to me going live on Facebook or Reddit or other places. So after I kind of got comfortable going live, then I went through the effort to rig internet to the laptop. I go live here. That's a biggie. All right, so we have our vacuum, we have our toy, we have our ears. Let's see if we can get a good tank. Rotational molders, they, as soon as there's any issue with most of their products, they just throw them in the trash. Our tanks this tank has 41 inserts, and you have so much time invested into getting to this stage. We do everything possible to save the part. Can you bring UPS? Thank you. Hey, Nick, having fun?
Loads. You have no idea.
So everyone, Nick's been helping.
Oh, shit.
He's been helping me make tanks, and it has been fantastic because then I've had the energy to actually do this part a lot more than if I was running the oven and doing this part. So I can do it to sit them down.
That's good. Nice version going out now.
Oh, yay. So yeah, everyone thank Nick for getting tanks in a timely manner, because without him, we would be weeks and weeks and weeks behind instead of, like, we would be months behind instead of 8 months-ish. So, yeah.
You should put him making the tanks on video.
Yeah, like, it's kind of tricky. You gotta figure out the angles and what works, and it's so freaking loud.
Yeah, the whole area is loud.
Yeah. Plus,
It's not much of hearing what you're doing, it's just watching.
I understand that concept.
I'm afraid, I'm sorry. No.
Oh gosh, this thing's heavy.
You got it?
There's 40 husk kits and 200 hoses. So yeah, it's a little heavy. It's 1990 was what it read on the scale. 19 pounds, 9 ounces.
Nice.
Yeah, that's cool.
Thank you. All right, we got UPS back.
Went ahead and did one mold. Tomorrow I'll do the other one. I'll clamp everything together.
Well, make sure we give me a double check on.
Okay, do you want to double check them now?
No, we'll do it tomorrow
Okay,
because
sure.
I have to make those inserts.
Yeah.
So
Okay, yeah, we can double check them tomorrow.
yeah, just before we close them up, just to make sure, because like.
Okay, I did check the months this time. I wasn't gonna take them apart if I didn't do it last time.
Well, thankfully, it takes a while for a month to change. So
Yeah. So that means like next month I would have to remember to change it before I clamp everything together.
yeah. Thank you. Okay. So we should have already been like done trimming that other tank and being all happy about our progress. No, that didn't work out that way. Let's try this. And then we're gonna do this. Oh. Oh gosh, that's sorry about all that noise. Okay, there we go. Well, that's a little different. All right. We're gonna do this spot up here. So this is all about just making it to where when the router goes across it, it doesn't make things bump. I mean, I said the last one looks flat, but this one looks flat too. I mean, we're gonna find out in a minute, aren't we? Sadly, very early in the process, you know, like we shipped tanks that had that problem, and it was up to the customers to kind of figure out the fix. And you know, that's just not acceptable to me. I very strongly am against making customers do like R&D and solve problems that should be already solved. It's like you bought a part, you want to go put it on and run it. So where the vent tubes were has kind of an ugly finish because it's up against Teflon. And so also rotational molding, well, all molding technically takes the fingerprint of what it's touching. And so although the Teflon tubes look smooth, they aren't. That's good. Let's just do a little bit more up here. Mostly I don't want to be distracted with my hand. Is that a Miss Ashley?
It is. Is that Krista with the pigtails? Hey, sexy.
Hey,
How are you?
good.
I gotta look at you in the face. You're looking so young and cute. Like
Aw, thank
the
you.
pigtails definitely make you look young. Mel's, good job.
I don't think she's watching right now, but great.
She'll watch it later. And at least she'll know she did a very good job with your hair.
Make sure you let her know.
I definitely will. She's been doing a good job.
Yeah, but she thinks they're not age appropriate. And I'm like, but I'm 12. Oh, dang, girl. This is a family-friendly channel on the YouTubes.
I'm sorry. Peace and love, everyone. Peace and love. There'll be no bitches of the over.
Uh-huh.
Peace and love.
Jeez. What am I doing? A tank. Yes. Okay. Oh, gosh. So earlier I was saying how like we're very transparent about our products, and that's for real. Like, there you go. Something went wrong on this tank for the customer, and we're just going forward, and it's life. We're gonna get a drink. So like, I'm gonna be doing live and not doing editing until like people really demand it and we're getting paid or something. I'm so busy with my life that I ain't got time for that. Like, I really don't. I want to share. I want to be like here for you to see, but I don't want to put in that extra editing because, well, for one thing, you wouldn't see that I've made a mistake. So why would I broadcast that? Right, that's nice and smooth. Put the weapons away. Okay, we have this. Eyes, ears, vacuum. So it was pretty crazy today. I went to one of our vendors on our way in. There's no hour. On my way into work, I stopped by one of our vendors. We buy hardware from them. And I haven't been there since like we built the oven. It was 2016, 2017. So it's been, actually 2017, 2018 maybe. I don't even know. It's been years since we were there. Since I was there, there's no weed. I guess there is a weed because that was before I transitioned. And I was getting ready to leave. I'm in this outfit, these pigtails. And the guy was like, "Oh, hey, you still doing those motorcycles?" And I was like, "Yeah." He's like, "Well, it's good to see you back." And I was like, "Thanks." I was like, "We're crazy. We bought a tow truck." He's like, "Oh, diversifying." I was like, "Yeah." I need to get this tank shipped before I play in the shop on fixing the stand for Billie Jean. I was hoping to get this tank shipped today, and that's not happening. That's going to be tomorrow. This tank better be good because I'm wearing a lot more of it than the last one. Okay. Oh, jeez. Can you see? Okay, loud noise. There's just this big old pile. That is crazy. Once again, we have the cores, and not the kind you drink, nor the kind that melt down. Vacuum. Oh, jeez. More vacuum. Did I take the back off of that? No. Whoops. So let's move you back down. So we're gonna make noise again. I'll have to do this part. So on this piece, you need to do this outer screw first because it's always just a little bit on an angle. So get him started to thread and then work away from him, just getting them started. Our early tanks were so not even that you'd have to use the screws to pull it down to reach the next one. And it's like, just looking back at the kind of, I don't know, the kind of like, the attitude the industry has about manufacturing, like the rotational molding industry he doesn't care about their parts very much. I mean, they do, because they care enough for their normal products. But we're like jet engines compared to old flathead V8s. When you start talking about the precision we pull off with all of these holes are just like so close. And when we made the tools, like they were also really close. The next mold we did after this one, I'm not sure if we even moved any inserts. We did such a good job with the design. Now on this piece, typically these two get grumpy. So it's like on the left side, these two, maybe that one, they get a little grumpy and they'll make some noise. And that's totally normal. Now that guy, is he trying to cross thread or what's the story? Let's just undo them all. And so like the last one, didn't these just fit perfectly? And here on this one, okay, he's got bunches of threads in. He's threaded. That one. Now, it's not like a real big deal that these aren't perfectly aligned because you're going to bolt up this plate and then that's it. You're never undoing it. The screwdriver's handle is a little more friendly to sweaty mitts trying to grip it. Oh gosh. Looks like we have pretty good compression all the way around. I don't see any huge gaps. Okay, let's put some air on. All right, seriously? Is there a problem with my tool? right, so I guess we're gonna go to advanced troubleshooting techniques. I mean, the last tool, it had an excuse. It was pretty valid. I mean, the last tank. It looked bad. So what we're gonna do now, take this O-ring out, maybe. There we go. O-ring looks good, path looks good. So we're gonna check for how the compression on the O-ring is going. What can you see? You can't see. Let's go back. So what I'm gonna do here is just hose down the O-ring. Now we're gonna put it back in. And we're gonna check the compression of the O-ring along its surface. It's just that, like, honestly, I haven't had 2 tanks in a row have the same fault like that ever. So this is a little strange. Hey, what's the channel called? Well, if it was easy, this would have worked, right? Why not? Well, I can see it. All right. We've got average compression here. That looks normal. I still don't like that it's leaking at the back. That's just really weird. I think it's time to go to the bar and get drunk. I think that's the right thing to do. So I'm checking this contact area. we're going to do this a few times looking for signs of how much compression we're getting. Well, that's pretty telling. So you can see up here, there's a gap. You can see right here, there's a gap, and it starts to get a little thin right there. So that would make sense with what we're observing. But like, that's flat. I mean, that really looks flat. All right, we're gonna bust out the Dremel. Good times. No one's here to watch me up, so that's good, I guess. Okay. Try number bunches. Yeah, so like having the patience to do things until you get it exactly perfect takes crazy. I have a lot of that to spare. I do. All right, we have all the screws started. It'd be really great to end this video and this day on a great high note. Might be about time to get those screws replaced. I don't know. They've been there a few years. I just don't care, I guess. It's like, it still works. I like what I'm not hearing. I like what I'm seeing. Alright, I'm gonna go dunk it, and you know, if I'd have thought ahead, I would have moved the trash barrel to like here, where you can see what's happening. Yeah, that spot's still a little proud. All right, we're going next level. So I set up a fence next to those two inserts. The fence came out of the toolkit that's for this tank, so this isn't my first rodeo. That's all right, I'm just having to earn it today. That's fine, because I'm extra gonna make sure I can't walk from the bar tonight. That's just all there is to that. All right, so we're gonna have a little sit down. So can you see? I don't know. There is a little dip between those two. So this guy's just kind of generally raised up on a little bit of a lump. So we're gonna pull him down. So this is like a little bit, this is the kind of the next step of trying to get more pressure from that insert while doing less overall damage. So like right now, we're protecting where the O-ring goes. And that means we're going to remove material, but hopefully we don't affect the O-ring itself. So you can see that area is pretty large. That's a pretty big lump. Now this is different from the last one because the last one, like the whole back of the tank dipped down and you can see it's touching here and here, so it doesn't keep pulling away. That other tank would definitely need like the whole area planed, and then we're sanding over where the O-ring goes. So that's like one step less desirable. Yeah, I kind of like like how this is going. We're just gonna kind of keep doing this for a minute. Let's see. Trying to get it to where the angle is comfortable. Probably what I should do is 3D print something that matches the O-ring that's raised up, and I could clamp it, and then I could file anywhere and know that the O-ring is safe. I mean, that makes sense. Oh geez, look at that. It does have a pretty big gap right there in the middle. Well, that just sucks a lot. Guess we'll do this side too. Why not? So the whole goal here again is to bring the metal closer to the surface of the plastic so you get a better pinch on the O-ring. The first round of the Dremel is to just basically knock the brass insert down to the level of the plastic. And then now we're going a little bit more and trying to get the whole thing planed down some. Let's give this a shot. UPS is here. We're gonna bail. hopefully this works. So the lightened areas are where the file took it down. And so hopefully we get a little more compression on that O-ring. This is not as crucial as the fuel pump area. Fuel pump area was fine. However, I'm not gonna sell someone a tank that won't at least pass pressure test. It's, you know, it doesn't work like that. And in case you're wondering, we also guarantee our tanks. So if they ever leak, we'll replace it. If you can make our tank leak, we will replace it. You should not be afraid of a piece of plastic. Doesn't matter if you're the one who bought the tank from us or not. You just want to see a picture of where it happened to see the type of problem. Most of our tank replacements are because an insert starts spinning and then it traps the fairing on the bike, and then it just, you know, there's a few things you can do to try to fix that. We ask folks to give that a whirl. Like 1 in 4, maybe 1 in 5 are successful at not needing a tank right away. These cannot be recycled, so it's kind of great when folks can not need another one. Cross-linked polyethylene does not melt. You can't move it. Once it's thermoset, this is where the molecules are going to be. So you can grind it up and make sand that you put in asphalt. You can burn it to return the hydrogen and carbon, but you can't melt it and make something else out of this plastic. Okay. 2 hours almost. Wow. Normally what would take 30 or 40 minutes is now an hour and 40 minutes. All of these are nice and tight. Everybody cross your fingers. Whoa. Point up. There we go. really long. No bubbles. Wow, that was a lot of work. And let's turn the air back on. Still, all right, I'll sit fine. So there you go. It's a lot of work caring about your products and your customers, and it's worth it. So next up is when we trim all of the rest of the flash. I'm not sure we're going to show that because it's not happening now. Maybe we will tomorrow. I don't know. But yeah, I mean, sometimes it looks easy, but then when you go that extra mile, so many things aren't so easy. And that's where caring makes a difference. It would have been very easy to just say send it because you're never going to notice like a little bit here. I don't think you're going to notice. I mean, that other one had a pretty healthy leak. That one, maybe they'd notice. If I had a Hypermotard, I would actually experiment to see if it would leak, like riding. I'd be like, oh, let's put it on my bike and try it. I'm down, I don't care. There we go. Nice continuous band on the O-ring. You can even see it in the reflection-ish there, yeah. So that's great to see when you've got that staring back at you. Some good squish all the way around. Oof. All right, lots of work. You did it. Thanks for sticking with it. You know, this might be a good example of renaming it to, wow, that wasn't easy at all. But, I mean, that's, geez, do I do things the hard way and like care too much? And if life was easy, maybe it would not have taken this much work. That's how it rolls. Okay. So thanks for watching, and we'll see you later. And bye.